In our sky, there is this one called Betelgeuse, or sometimes Betelgeuse. It's a red giant star, and if you placed it where the Sun is, it would stretch out to the orbit of Jupiter. It's gigantic and incredibly unstable, and it's likely going to explode. This idea was supported by the fact that there were huge changes on the star's surface. Eventually, the Hubble Space Telescope, humanity's watchdog in space, helped us figure out what was happening with this unusual event. Hubble's observations showed that the dimming of Betelgeuse was likely due to a large amount of hot matter being ejected into space. This material formed a dust storm that covered part of the star's surface, reducing the amount of light from Betelgeuse that reached us. It was thought that the dust cloud was created from extremely hot plasma that erupted from a massive convection cell on the star's surface and moved through its hot atmosphere to the cooler outer layers. As it cooled, it formed dust grains, creating a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet spectroscopic studies, which began in January 2019, were instrumental in figuring out the events that led to Betelgeuse's dimming. These studies showed signs of thick, hot matter moving through the star's atmosphere. Several ground-based telescopes also observed the star's dimming in December 2019, particularly in its southern half. Initially, the material was brighter than the star itself, but as it moved outward and cooled, it turned into a dark cloud. The leading theory was that this ejected matter and the resulting dark cloud were responsible for the star's sudden dimming. This eruption was truly massive, putting Betelgeuse at the center of astronomical attention. The star ejected around 400 billion times the mass typically shed in a normal coronal mass ejection. This material, estimated to weigh several times as much as the Moon, marked a huge event for both Betelgeuse and our understanding of stellar processes. But what does such a massive outburst mean for our understanding of red supergiants and supernovas in general? It has significant implications for our theories about supernovas. Red supergiants like Betelgeuse are thought to lose mass at a fairly steady rate before they explode at the end of their lives. However, the scale of this ejection challenges this notion, suggesting a more turbulent and potentially unpredictable end-of-life stage for these stars. Could Betelgeuse be preparing for its final step, a supernova explosion in a few thousand years? New studies speculate on when this might happen, suggesting it could occur sooner than previously thought, maybe in just a few decades. Another important aspect of the Betelgeuse puzzle is the concept of a bow shock. This massive star plows through space at about 67,000 kilometers per hour relative to the interstellar medium around it, creating a bow shock similar to the wave formed by a ship's bow. This effect occurs when the star's outer layers interact with the gas and dust in the space between stars. It's a beautiful display of the star's activity and its interaction with its surroundings. The bow shock not only informs us about Betelgeuse's current state but also helps us understand stellar evolution and mass loss. What about the star's past behavior? After the mass ejection, Betelgeuse's surface cooled and became less dense, indicating that the star remains unstable even years later. Hydrodynamic models show a connection between the star's convective activities, the mass ejection, and subsequent changes in pulsation modes. This ongoing instability raises questions about the internal processes driving these changes and what their ultimate outcome might be. Moreover, Betelgeuse's mass loss rate is significantly higher than that of many other stars, suggesting a complex internal structure and processes unique to it. Exchange of inward powers. The power throb adding to this mass misfortune is compelled by the persistent energy misfortune through shock warming and mass discharge. These perceptions show that Betelgeuse's life cycle is profoundly dynamic and not actually unsurprising, provoking researchers to reconsider their models of heavenly advancement. With all these huge changes, one may keep thinking about whether Betelgeuse is going to go supernova. This question is of incredible interest to astronomers. The specific timing of such an event remains obscure, yet the recent uncommon mass ejection has moved the conversation, persuading some to think the end may be closer than already thought. Hypotheses are now endeavoring to figure out what this massive loss of matter means for the star's well-being and future. While astronomers focus on Betelgeuse, the supernova SN 2023X is also gathering attention and can be used for quick examinations. This remarkable blast occurred in Messier 101, otherwise known as the Pinwheel Galaxy, which is only 21 million light-years away. SN 2023X, discovered in May 2023, isn't just another supernova. It's the closest one seen in recent years, providing researchers with a brilliant opportunity to study a star's final moments. The discovery of SN 2023X was a cosmic coup. Koichi Itagaki, an amateur astronomer known for finding supernovae, first detected this rapidly brightening spot on the edge of Messier 101 with a small 0.35 m telescope. When he announced his discovery, the astronomy community sprang into action. From ground-based observatories to the Hubble Space Telescope, telescopes around the world turned their attention toward this new supernova. The race to monitor SN 2023X light curve yielded critical data about the blast and the environment surrounding the dying star. Researchers meticulously recorded SN 2023X's behavior during the turbulent month following its discovery. In just 5 days, the supernova brightened significantly before beginning a steadier decline, dimming by 0.03 magnitudes each day. Spectroscopic analysis revealed numerous bright emission lines, indicating intense interactions between the expanding supernova shock wave and the surrounding gas. This wasn't just the death of a star, it was an enormous star collapsing under its own gravity as its nuclear fuel ran out, resulting in a dramatic core collapse. What's especially intriguing about SN 2023X is the dense shell of gas surrounding it, which made it more challenging for the shock wave to escape from the star's core. Two potential explanations for this dense material are either a strong, steady wind expelling material from the star before the explosion or random ejections that shed material into space. Regardless, the star is believed to have lost up to a solar mass of material in the last 1 to 2 years of its life, indicating its final moments were far from peaceful. The primary goal of current research is to identify the progenitor star of SN 2023X. Scientists have used a variety of methods and measurements to propose a likely candidate, a red supergiant. By studying the specifics of the SN 2023X explosion, such as the characteristics of its progenitor star and the processes leading up to the final blast, astronomers can refine their models of stellar evolution and supernova mechanics. These new insights directly inform our understanding of Betelgeuse's current state and how it could end up going supernova. They offer a better sense of the signs to look for and how to interpret the complex behaviors of massive red giants. But when will Betelgeuse go supernova? Experts at Tohoku University suggest that Betelgeuse may be in the carbon-burning phase of its life, a stage stars typically go through before they die. Hoki Seo, who leads this research, believes that the star's core could collapse a few thousand years after its carbon supply is depleted. On the other hand, scientists at Hungary's Konkoly Observatory think Betelgeuse is in an earlier helium-burning stage. While there are differing opinions, most agree that Betelgeuse will likely be the next supernova in the Milky Way. However, this event might not occur for another 100,000 years. Previous observations of supernovae have provided significant insights into the death of stars. The first known record of a supernova was made in 185 CE, noted as a bright star that vanished from the sky after 8 months. Since then, many significant supernovae have been observed, including SN 1054, which created the Crab Nebula and was visible during the day for 23 days. The most recent supernova observed in the Milky Way was SN 1604, studied extensively by Johannes Kepler. More recently, supernova 1987A in the Large Magellanic Cloud was observed just hours after its light reached Earth. It was the first supernova seen through neutrino radiation and across all electromagnetic spectrum bands. These observations have been essential in creating accurate models of supernova behavior and understanding their role in star formation. Imagine it, the night sky unexpectedly ejected in a splendid showcase of enormous firecrackers, and the brilliant blast of a star caught our attention. Imagine if the natural constellation of Orion had a new, brilliant star added to it. Betelgeuse, one of its most brilliant stars, had gone supernova. What sort of effects might this unbelievable event have on Earth? Betelgeuse is on the verge of a core collapse supernova, a blast that occurs when massive stars exhaust their nuclear fuel and can no longer support their own gravitational collapse. Core collapse supernovae are among the most powerful and catastrophic events in the universe. Betelgeuse's supernova will take only seconds, but it will release as much energy as our Sun will in its entire billions of years of life. Most of the energy released by a supernova is in the form of electromagnetic radiation, including X-rays, gamma rays, and visible light. A Betelgeuse supernova, however, would create a spectacular light show in the night sky that we could see immediately for a short period. The blast would be brighter than the moon and visible even during the day. Imagine looking up at the sky during the day and seeing a second, much brighter sun appear for weeks or even months. Both astronomers and casual stargazers would be captivated by the event. But as fascinating as it is to witness a Betelgeuse supernova, its real significance lies in the scientific questions it raises. Supernovae, especially those resulting from the explosions of massive stars like Betelgeuse, are like laboratories in space, offering us a wealth of information about the fundamental workings of the universe. One of the primary benefits of observing a Betelgeuse supernova would be the opportunity to closely study the final stages of a star's life. When massive stars like Betelgeuse explode, they release heavy elements, such as iron formed within the star, into space. This process contributes the building blocks of planets, stars, and life itself to the universe. By examining the spectroscopic signatures and the dispersion of these elements after a supernova, scientists can gain valuable insights into stellar evolution, element fusion, and the formation of new celestial bodies. This information is essential for understanding the history and composition of the universe. While the visible light from a Betelgeuse supernova would be spectacular, the neutrinos released would be equally fascinating. Neutrinos are subatomic particles that are extremely difficult to detect because they rarely interact with matter. However, in the extreme environment of a supernova, vast quantities of them are produced. These elusive neutrinos provide a unique glimpse into the heart of a dying star, offering insights into the core collapse process that help us understand the fundamental forces and particles at work during a supernova explosion. Detecting and studying these neutrinos would be a major scientific breakthrough, potentially leading to new discoveries about the universe's most extreme conditions. The discovery of a Betelgeuse supernova could also reshape our understanding of the universe's expansion and the mysterious force known as dark energy. In the late 1990s, scientists studying distant supernovae discovered that the expansion of the universe is accelerating, contrary to previous assumptions. Since Betelgeuse is relatively close to Earth, its supernova would provide an exceptional opportunity to gather data on the universe's expansion rate and the role of dark energy in driving it. This could expand our understanding of these fundamental concepts and perhaps reveal new mysteries about the universe's structure and fate. But what could happen on Earth if Betelgeuse were to explode? Is our planet in danger? Fortunately, given the vast distance between us, this is highly unlikely. 1 light-year is approximately 5.88 trillion miles, which gives you a sense of the scale of our universe. At 725 light-years away, Betelgeuse is more than 4,267 trillion miles from Earth. This enormous distance provides a level of cosmic shielding, making it extremely unlikely that the explosion would have any direct harmful effects on Earth.